So earlier today we were working on solving multi-step equations, something similar to this or problems like this. And I was not expecting the confusion that I saw from many students, as this should be a review from last year. And so it should be a review. But in case you don't remember how to do it, I'll make this quick video, and I'm sorry about my voice. This is the best that I can do right now. So if this is not dedication, making a video and I can barely talk, I don't know what is. But anyway, how we solve this is we use the distributive property when we have a number outright touching the parentheses. This is just like what we practiced last week. So 6 times x plus 2, outside times inside, 6 times x. Then I have plus, so I will keep the plus, and then 6 times 2, I will write here, and then it equals 72. So now we can simplify this. 6 times x, 6x, plus 6 times 2 is 12, and then in the end it equals 72. Now we're at a point in an equation that you definitely have been doing since 6th grade probably, where you have 6x plus 12 equals 72. So I get rid of the constant. If I have plus 12, the opposite minus 12 on both sides of the equal sign. I'm left with 6x equals 72 minus 12, 60. So then I divide by 6. And I'm left with x equals 10. Over here, same idea. And just like last week when we practiced the distributive property only works with the portions that you're multiplying. So you're only multiplying 3 by the parentheses. The 3 is touching the parentheses. This minus 4 is completely separate. It's not part of the multiplication at all, that we're multiplying these two things. We're doing minus 4 separately. So we use the distributive property here and then subtract 4. So first, 3 times x. This time we have subtraction. I keep my subtraction. Then we have 3 times 5. And then I keep everything else in the equation the same. So minus 4 equals negative 31. Now we can simplify. So 3 times x is 3x. I keep my minus sign. 3 times 5 is 15. And then I have still the minus 4 equals negative 31. So now I can combine anything here. So here I have 2 constants, 2 numbers by themselves without an x. So I can combine them. I have minus 15, minus 4. So like negative 15 minus 4, I can change this to plus negative 15 plus negative 4, negative 19. So now I have 3x minus 19 equals negative 31. So now we're back to that normal 2-step equation. So if I have minus 19, I do plus 19. Cancel. I'm left with 3x equals, now I have negative 31 plus 19, so I could draw out the 31 negatives, 19 positives, and in the end, after canceling out, I'd have negatives left over, and specifically, I would have 12 negatives left over. Divide by 3, x equals negative 12 divided by 3 is negative 4. Over here, same idea. This is the distributive property part right here. This 5 times this parentheses. This 20 minus is separate. But we also have to think about this minus sign. It always goes with the number that comes after. So instead of just a 5, we have a minus 5. So I'm going to keep the 20 and then minus 5 times 2. Then I have a plus, so I keep my plus, and now here we have a minus, so I need to be sure we're subtracting everything here. This whole distributive property part right here is being subtracted. So this multiplication is being subtracted along with this subtraction, or sorry, this multiplication is being subtracted. So I also have a minus 5 times x, and then in the end that equals 5. So when I have a plus and a minus like this, it turns into a negative 5. This is subtracted, the 5 is being subtracted, and the x is positive, so negative times positive, we're gonna get a negative 5. Okay, so now we go through and we simplify. 20 minus 5 times 2 is 10, plus negative 5 times x, negative 5x, and then equals 5. Then we can simplify. So I have 20 minus 10, positive 20 minus 10, 10 plus negative 5x equals 5. Now I simplify. Positive 10, the opposite is minus 10, cancels. I'm left with a plus negative 5, so I just write the negative 5x. 5 minus 10, negative 5, divide by negative 5. Cancels, I just have x. Negative 5 divided by negative 5 is 1. Over here, same idea, even though it's a fraction, I have this number times this parentheses. So I'm still going to do outside times inside, outside times inside. Even though it's a fraction, it still is a number, and when we have a number next to the parentheses, it means multiply. So we're doing 1/3 times all of that. So first, 1/3 times x plus 1/3 times 9, and then it equals 7. Now we can simplify. 1/3 times x is 1/3 x. We have plus, so I keep the plus. Then 1/3 times 9, I can do some work off to the side. Nine over 3 equals 3. So this here equals 3. Here's my work here to show why. Now I just solve like normal. So I start with my constant. So if I have plus 3, opposite is minus 3. Plus 3 minus 3 cancel. I have 1/3 x left. 7 minus 3 is 4. So here I have 1/3 times x. So if I'm doing times a third, the opposite is divide by a third. Even though it's a fraction, we still follow the same rules that we did in all these other ones. Doesn't matter if it's a whole number or a fraction, always the same rules. X equals 4 divided by a third. Can make 4 into a fraction. Then I keep, change, flip to the reciprocal. 12 over 1 equals 12 is the answer there. Here's another one. Same idea, is kind of like these two combined into one. So this 18 minus, it's not next to any parentheses, it's not being multiplied by anything, it's totally separate. So I'm going to just keep that for now. So I'm going to keep my 18, and then I'm subtracting all of this. So both of these multiplications will be subtracted. So first I have 1/3 times x. Then I have plus, but then I also have a minus a third times 9. So remember this minus sign, it goes for both multiplications. So I'm subtracting this multiplication and this multiplication, which essentially turns this 1/3 into a negative. So like here I have negative a third, and here I have negative a third. If you have the subtraction symbol, you don't need to write the negative again, just one or the other is fine. Since I put plus here from here, I changed the 1/3 to negative since I didn't already have a minus sign like I did here. This minus sign makes the third, essentially makes it negative. Here I had a plus sign, so I had to write in my negative symbol to make this 1/3 negative. So then in the end, it equals 7. Now let's simplify. 1/3 times x is 1/3 x, less negative 1/3 times 9, negative 9, so negative 3. And then in the end, it equals 7. So then we can simplify. So I'm noticing there's two terms here that are constants. They have no x by them, so I can combine them. So I have positive 18, and I'm adding a negative 3. So I'm going to do positive 18 plus negative 3, positive 15. Oops, 15. And then I'm subtracting 1/3 x, and then it equals 7. So I combined these two to make 15, and then I still had my minus 1/3 x. So now it's just a normal two-step equation. So I start with my constant. It's positive 15. So the opposite is minus 15. This cancels. I'm going to write it over here so I have more space. But only the 15s cancel. I'm still left with minus 1/3 x. This minus sign here did not cancel out at all when I canceled out the 15. So it's still, oops, I accidentally made a mark there. It's still minus 1/3 x. Right here, it's fine. Minus 1/3 x, 7 minus 15, negative 8. So I'm doing negative 1/3 times x. The opposite is division by negative 1/3, the exact same number. These cancel. I'm left with x equals, so now I'm going to do negative 8 divided by negative 1/3. So I keep, change, flip to the reciprocal, negative 24 over negative 1 is 24. So x equals 24. Another type of problem you could have would be like this, where there's no distributive property, but we can combine some like terms is what they're called, things that are in common. So I see on this side we have two terms with an x, so I can combine them. If I have 5 x's and I'm adding 2 more x's, in total that means I have 7 x's. So I combined these two to make 7x, and then I'm still left with this plus 4, then equals 17. Now I solve like normal. Minus 4, 7x equals 17 minus 4 equals 13. 7 times x, so I divide by 7. X equals 13 sevenths. I can simplify. 7 goes into 13 one whole time with 6 left over, so x equals 1 and 6 sevenths. Last one over here, same idea. There's no parentheses with a number right next to it for the distributive property, but we do have a couple terms that are in common. They both have x's, so we can combine them. Here I have minus 3x, and here I have minus x. So I'm doing negative 3x minus x. So I'm thinking about if I have negative 3 x's and I take one away, how many would be left? Well, I can change this to an addition problem by going like this. Plus negative 1 equals negative 4. So I have negative 4 x's. So I combined these to that, and I'm still left with minus 6 and equals negative 18. Now I solve this. If I have minus 6, I do plus 6. So then I'm left, these cancel, the minus 6 plus 6. Negative 4x equals negative 18 plus 6. Could draw 18 negatives, 6 positives, cancel them out. I'd be left with negatives, and specifically 12 negatives. So now negative 4x equals negative 12. So I divide by negative 4 and divide by negative 4. So negative 12 divided by negative 4, negative divided by negative is positive, 12 divided by 4 is 3, so x equals 3. These were many different types of problems that you could see where you have to do more than a couple steps to solve, but your goal is to get to a two-step equation and then solve it just like we've been practicing with the two-step equations.